Right, installers, I thought I would do a quick training session for you for the Sungrow metering and current transformers. Now, the reasoning behind this is there's a lot of you out there seem to get yourself into a wee bit of trouble with the metering. It's actually very simple and straightforward. It's just this is a relatively new concept, I suppose, for installers. So I've broken it down into kind of simple sections here. I've made this pretty quick. I don't want this video to go too long, so I'll go through it fairly quickly. But if you do need training on the metering, or you reckon your team might need training, please get in touch with me at training@sungrowpower.com.au. Okay, so let's move on with this. And the section is called Understanding How the Meters Work. Okay, now I'm going to go back to basics here for a simple reason. It's just to clarify everything that we're talking about and all the terminology and all the rest of it. It's a good idea just to go back to cover the basics. So we all know that watts equals volts times amps. Of course, that was what we did when we were at TAFE. Now, residential and small commercial customers are generally billed in kilowatt hours. Everything in solar is in kilowatts or watts. The panels are watts, the inverters are kilowatts. Your exports in kilowatts. I say the customer is billing in kilowatt hours. So we do need to talk in watts and kilowatts here. So we're going to need a watt meter. Okay, now if you look at your multimeter, you've got a voltmeter on it. You select the voltage range and you put the probes on and you measure the volts. And if you've got the clamp meter, you clamp it round a cable and you measure the current. So a watt meter is a kind of combination of the two of these working together. So metering is required in the Sungrow systems where consumption data is required. Export feed-in needs to be limited. If you've got export limitation, you need a meter to be able to do that. And if there's a backstop or anything like that, you'll need a meter there as well. And of course, if you have a hybrid battery system, you will need a meter so that it will operate okay. Now, I've put a little thing here about whole house backup being enabled. I'll cover that later. In the whole house backup configuration, you generally don't need a meter because the inverter is acting as a meter. However, okay, let's move on. Now, only use official Sungrow meters and parts. The meters are made by Chint for Sungrow, and the Sungrow ones have a label on the box that says Sungrow. Okay, so if they don't have that label, it's not a Sungrow part. And it probably won't work because the settings, for example, you can see here the Modbus ID 254, that's the meter address that we use. If you buy an ordinary meter, it won't be set to that, so it won't work. And this is for the CTs here, which I'll cover in a minute. So in the current Sungrow meter range, we've got the old trusty S100 single phase energy meter. That's a single pole unit and it comes complete with a CT already connected to it. Okay, communicates via the RS485 as they all do. There's a couple of LEDs on it. There's a yellow one here and a red one on the right. The yellow one will glow steady yellow or amber when the power is applied, like the voltage. You'll know it's powered up. And if it's flashing, you know it's communicating through the RS485. The one on the right you can ignore. It's a red one and it's a pulse output kind of thing. All that means is there's power flowing through the CT, but you can just ignore that because we don't use it. So if you see the red flashing LED, don't worry about it. DTSU 666-20, which is probably now appearing in most boxes. It's a 2-channel 3-phase meter. You can use it for single phase, 2-phase or 3-phase supplies, okay? It has 2 channels, as I said, Channel 1 is for monitoring the mains, and channel 2, if you want to use it, you can monitor the output of a third-party inverter. You don't need that if it's a Sungrow one, but if it's another brand, you can monitor the output of the other one. So there's basically 6 CT terminals on there, and they usually come in the box with whatever CTs you need, depending on if it's a 3-phase or a single phase. Different configurations. DTSD1352, this is the commercial version. Now you can use the DTSU 666-20 in the commercial situation, it's not a problem, it works fine. The DTSD1352 might be a bit better for commercial, mainly because there's more information you can upload on iSolarCloud from this kind of meter. It has a different CT ratio. The DTSU 666-20 uses 333 milliamp CTs, and these ones use 5 amp secondary. Therefore, you have to set the ratio in the inverter or the logger. Don't worry too much about that at the moment. The CTs are not supplied with the meter, so you need to purchase your own CTs. You can also use these Rogowski coils on this meter, so that's an option for you as well. You just need to make sure that the CTs must be rated to or above the switchboard. In other words, if you've got an 800 amp switchboard, you need to put 800 amp or larger CTs on it, okay? Also communicates via RS485, which I will cover later. Now, how the information is gathered. Okay, all the current Sungrow meters are CT meters. In other words, they use a reference to measure the voltage and the CTs to measure the current. What I was saying at the beginning, you've got a voltmeter in the meter and it measures the voltage, and you've also got the CTs that measure the current, and volts times amps is watts. So that's how it gets the information. So you obviously need both. Now I'm going to do a little bit about current transformers here, just to clarify some of the terminology as well. Generally speaking, this is kind of like what a current transformer is like. You've got the main conductor, your main cable, your active cable, and the power's running through there. And of course, as you know, there's a magnetic field, which induces a magnetic field in the hollow core of the CT, and therefore induces a current in the secondary winding here, okay? If it's the 5 amp type, for example, if it's a 100 amp 5 amp type, if 100 amp flows through this conductor here, it will produce 5 amps here. This is what it looks like in a circuit diagram. You'll notice here it says IP and IS. I'll explain what that is later as well. It's primary and secondary. Okay, polarity. Now, you've got to put them on the right way. There is an arrow on the CTs. If you do put them on the wrong way, it'll read import as export and export as import. Okay, so you have to put them on the right way. And one of the good ways that you can actually remember this is CTs have been around for a long time, maybe over 100 years. And it's only recently that power has flowed from the house out to the grid. Up until this point here with solar, the power has always flowed from the grid to the house. So that's the direction of the arrow. So it makes it nice and easy. As I said before, we use 2 different types of CT depending on the meter. On the DTSU 666-20, we use the 333 millivolt secondary, and on the DTSD 1352, we use the 5 amp secondary. And that's kind of what they look at. Like, look, there's different brands. The ones that we supply with the meters look like this. Your wholesaler, wherever you buy your gear from, will have them in boxes. If you're buying more CTs, make sure they are the Sungrow ones, and they will be the 333 millivolts. The default is 100 amp, but you can buy larger ones. On the 5 amp secondary type, there are different brands. I don't want to advertise any specific brand here, but they will be marked. You'll see it says 100 amp in the secondary. In this case here it's 2K5. The K is relevant, and I'll show you what that is later as well. So it's 5 amp secondary. Now if you do get them mixed up, your readings are going to be weird. For example, you can connect the system into a house, and then you look at it on iSolar Cloud and the consumption is like 3 megawatts or something. If you get that kind of result, you know you've probably put the wrong CTs on. Now, CT ratio. Ratio tells the system what factor the output of the CT needs to be multiplied by to equal the actual current flow. For example, let's just say we're using a 400 amp with a 5 amp secondary. Okay, if the main switchboard rated at 400 amps, we have to put a 400 amp / 5 amp rated current transformers. So if you do the calculation there, you divide 400 by 5 and you get 80. So the ratio is 80 to 1. I'm not going to go into that too deeply at the moment. As I say, if you want some in-depth training, give me a hoy. For the 333 millivolt type, for the DTSU 666-20, the default is 100, okay? And there's no requirement for you to ever do anything. If you are going to fit a larger CT, it's easy to do it. Contact us and we'll show you how to do it. Okay, now this is a split core CT. This is a 5 amp one, opened up just to show you the bits of it and the arrow. Now P1, P2, okay, P stands for primary. 1 is the grid side, 2 is the loads and inverter side there, and you can see the arrow pointing from the grid side to the load side. Okay, so this is the primary coil here. So your main conductor goes through here, and this obviously closes over the top of it and clamps over the top of it. The secondary side, usually marked S1 and S2. It's also K and L. You might, depending on the brand, it might be marked K and L. Okay. S1 is what I would call the active side, and S2, the secondary, is kind of like a ground side, although it's not really. It can be grounded depending on the meter. Okay, so just make sure that you do connect these the right way. It will be marked on the actual meter itself where to connect these two. Okay, so I'm getting into the stuff this is where people make the mistakes. Okay, so I've a bit of a resume, a bit of a review of the bits of the meter. We're going to go into the location of it and the wiring. This is the important part, and this is, I say, the part that people make mistakes, and it is understandable because I know what switchboards look like. Inside there can be wires going in every direction. They're all red. People have added to over the years, and it can be an almighty mess, and it can be difficult access. It can be dark, so it is very easy to do the wrong thing in the switchboard. So this is where you really need to just take the care. Okay, so let's have a look at the meter location now. The whole purpose of this meter, its whole purpose is to measure energy flowing from the system out to the grid, or energy flowing from the grid into the house. That's all it does, okay? It's measuring that current flow going in or out the house, okay? So the meter must be located between the grid and everything else, okay? You'll pick up your voltage, your reference voltage, on the consumer side of the main switch, so that obviously if you flip the main switch off, the meter goes dead. That's correct. The current transformer or current transformers, they can literally go anywhere along this line here, okay? Because that's just a one power flow across there. You can ignore the meter, but basically you've got to put the CT before any of this stuff here. Doesn't matter how many inverters, how many subboards, whatever you've got here. Ignore the controlled loads because they're on a different tariff, okay? So just ignore that like it's not there. So wherever's the most convenient point in this active cable, you just clip the CT or CTs over the top. Make sure the arrow is pointing that way, and that will work properly, okay? So that's the important part. That's where you need to put the meter. Now, bear in mind there's a maximum length of CT cable. Generally speaking, you can't extend them. If you are going to extend them, you can maybe put a bigger cable on them to reduce the volt drop, but it's not recommended, okay? And of course, you've got your RS485 cable communicating with the inverter. I'll cover that in a minute as well. Now, phasing and power factor, okay, because we're now doing three-phase units, this has come into play, and this is another area that people quite often make the mistakes. So I'm going to do a wee bit of some vector diagrams and things here, just to demonstrate what I'm talking about. This is about getting the correct phasing. Okay, now you all should remember from your days at college, on a purely resistive circuit, for example, the voltage and the current are always in phase, okay? Now, if you've got inductive loads, you'll get leading and lagging currents and voltages, okay? I know this is a bit exaggerated here. It's got a 90-degree thing. Don't worry about that. It's exaggerated to make it easier to see. So in this case here, you've got the current leading the voltage there like that. And you will know that that gives us a power factor. This one here, the power factor is unison or 1. And once we go here, the power factor gets a lot lower. Now, the difference between kVA and kilowatts is the power factor, okay? Okay, so three-phase rotation, like that. The voltage and current should peak very close to each other. The bigger the lead or lag, the worse the power factor. Okay, so normally they should be pretty close together, 0.9, maybe down at 0.8 if it's really bad. And that way the power factor is not bad. Now that's, if we remember our college days, we can all understand that. But and how that works, as previous here, if you've got the waveforms in unison, if you've got the current and voltage, on this one here, just say that's 2 and that's 2 amps, 2 volts. 2 volts times 2 amps is 4 watts, okay? So they actually add together, and it's the same for the 0 point. The 0 by 0 is 0, and the same with the negative as well. -2 times -2 will give you the -4, okay? So that's in unison, a power factor. So if you've got watts times amps, you should get the power there. Now, if they're out of phase, okay, there's going to be a bit of a difference. So for this one here, supposing that's the current there, the red one, and the blue one's voltage, at this point here, what is the watts? And if we take the previous diagram and say that that peak is 2 there, so that's 2 volts there. Now that's not 2 amps there, that's probably a lot less than even 1 amp there. So let's just say, for example, it's 1 amp. 2 times 1 is 2 watts. Not 4 watts, it's 2 watts. So it's exactly half of what it should be, even though the voltage and current are there. Okay, so in a three-phase system, if you've got the red phase, CT, supposing you've got your red phase, phase A voltage connected into the phase A voltage input in the meter, so you've got your phase A voltage there. Now, supposing you take the red phase CT and you clamp it over the yellow, the white phase or something, what's going to happen is that the power factor is going to be really shocking. In that case there, it will actually be about 0.5, okay? So instead of something being, for example, 5 kilowatts, it's going to show us 2.5 kilowatts on the system. Now this is going to play real havoc with the calculations in iSilicloud, and it's going to look really weird on the graph as well. It can be difficult to spot, but it's going to affect the performance of the system. So you need to be really careful, and this is what I'm trying to emphasize here. You need to be sure to put your CTs on the correct phase. If you put them on the wrong phase, it means you have to go back out on site and do it again, which is going to cost you money, okay? Which we want to avoid, which is why I'm doing this, okay? So that's the importance of getting the phase rotation correct. And I say, I know this is difficult because the switchboard might have 3-phase red, red, and red. So it can get really difficult. So you just need to take that extra few minutes to make sure you do this correctly. Okay, communications. This is another one, meter not communicating. Now, they always communicate on the RS485, which is the A, B. It's marked on the meter as A and B. And on the inverter, it's always marked meter A2, B2. That's always the connection in all of our inverters. It's A2, B2. That is for the meter, okay? So you always connect the AB to A2, B2. Cable. My preference is a shielded twisted pair at 0.5 mil. It's just a better quality cable than the Cat6. Some people use Cat6 and they reckon it's okay. Well, it could be okay, but Cat6 isn't designed for RS485. Shielded twisted pair is designed for RS485, so it will work better, always better, a better quality data. Now, we also supply resistors, 120 ohm resistors. Without going too elaborate on these, basically you can bend it over. If the cable's more than 10 meters, I recommend you put a resistor in. It will never do any harm if you do it, okay? It's not going to affect anything negatively if you do it. But if you don't do it and the cable runs long, okay, you can lose signal quality. The purpose of that resistor is to reduce data reflections in the cable, which I say over a long run, it can affect the quality of the data and it can cause miscommunications, okay? So as long as you connect it properly, using the little crimp, bootlace crimps that we supply, the little light blue ones, it'll work fine. Now, there's some golden rules. If you remember these, you'll be fine. If you can see the data, the voltage and current displayed on the meter's working. So you look at the meter and you can see information there. There's a menu you can scroll through. You can see the voltages, you can see currents. Meter is working. There's nothing wrong with the meter. So you can ignore that part of it. Meter data, if there's no meter data on iSolar Cloud, or you get error 514, it probably means that RS485 wiring is wrong. You've got the AB the wrong way around or something like that. If the data on iSolar Cloud is incorrect or inaccurate, as I mentioned earlier, you've either got a CT facing the wrong way or on the wrong phase. Okay, so if the data is not making sense, your meter's working, it is communicating, but it's probably a CT issue and it's on the wrong cable or something like that. One of the ways that you can tell straight away is you look at the overnight data, and if the system's exporting power at night, you know the arrow's the wrong way. That's an easy one. Okay. On the RS485, I'll just go back a slide here. Okay, if you want to test the RS485, there's an easy way to do it. Just take the resistor out, take the cable out, and put your multimeter to DC and go across AB. It should be about 3.5 to 4.5 volts DC, okay? You can do the same at the inverter end as well. If you get that 3.5, 4.5 volts DC, the RS485 is fine, it's working, okay? And if it's not communicating, it has to be maybe wrong polarity or something, or just not connecting, or wrong cable. For the S100s, the yellow LED, as I mentioned before, the yellow LED is flashing, it means it's communicating. If all else fails, reboot everything. Doesn't do any harm. I've come across that one before. Just reboot and the communication wakes up. Okay, I've kept it nice and short. If you want in-depth training, let me know. My email is training@sungrowpower.com.au. For normal service at sungrowpower.com.au or 1-800-786-476. The service hotline is open 8:30 till 7, 6 days. Starts at 10 a.m. on Saturday. Generally speaking, public holidays, we might have a skeleton staff, but we put out the bulletins and that. Another couple of ways you can get in touch with us. If you go to our service.sungrowpower.com.au website, you can do it on your phone. You scroll down at the bottom right hand corner, there's an installer live chat. You can click on that and you can upload photos and stuff like that, and you will get through to one of the team here. Yeah, it's not one of these automatic things like, you know, a bot. It's an actual guy in the service centre, like that. Facebook page, I post a lot of information up on there. You're welcome to join. Just go to Sungrow Aussie Installers group. Apply to join. Make sure you answer all the questions, because if you don't answer the questions, we just say no, you don't join. It is for installers. It's not for installers and retailers are welcome to join, but it's not for members of the public. It is an installer group. So with that, I think we can call it a day. I did whiz through it pretty quickly there, and hopefully that's going to help.